In this video, we're going to use the Maclaurin series, Taylor series, power series we know to help us find the sum of the series from n equals 0 to infinity, minus 1 to the n, quantity minus 5 to the 2n minus 3, all over 2n factorial. So the first thing that I like doing in this problem is, of course, listing out all the power series I know something about, like the 4 we see here, 1 over 1 minus x, e to the x, sine of x, and cosine of x. The next thing I really try to do in these problems is identify the factorial if there is one. So in this case, we have a 2n factorial, in the denominator. And that will help us identify which power series and function this is going to be related to. In this case, looking for the 2n factorial leads us to cosine. So it looks like what we're going to use in this problem is the power series or Maclaurin series for cosine, minus 1 to the n, x to the 2n, all over 2n factorial. And that's equal to cosine of x. And similar to the problems in which we try to find the power series or Maclaurin series representations of functions, the first thing I like to do once I have that series relationship is we need to think about how can we turn this into a composition of functions, or basically how do we create those stencils that we've used in the past. So anywhere there's an x, I surround that x with open parentheses, and then I erase that variable x in between. Again, the reason being, whatever we put in the parentheses on the left, we can put in the parentheses on the right and maintain that equality. So let's start off with what we're given here, because what we're going to try and figure out is what do we need to put into these parentheses inside of that series. So we're given the series from n equals 0 to infinity, minus 1 to the n, times minus 5 to the 2n minus 3, all over 2n factorial. And what we need to do is try to identify what are the things that are similar to cosines series and what things are different. Well, we'll have to use some algebra to help us out. And well, for the cosine series, we have a minus 1 to the n. So that checks out already. We, of course, have that 2n factorial in the denominator. So the only thing we need to figure out now is how to handle what's in that numerator. And in this case, what's a little bit off is instead of having something raised to the 2n power, we have something raised to the 2n minus 3 power. So that's going to be the difference here. We want something raised to the 2n power, not 2n minus 3. Just again, compare, we have a 2n in cosines, but now we have a 2n minus 3 in the series we're given. So this is where we're going to be able to use a little bit of algebra. So we have the series n equals 0 to infinity, minus 1 to the n. We have that 2n in the denominator, or 2n factorial in the denominator. And what we're going to do with that term in the numerator there is we're going to break it apart into two separate factors. We'll have the minus 5 raised to the 2n that we need for cosine, but then we'll also have this additional factor of minus 5 to the minus 3rd power. And now if we notice, this last minus 5 to the minus 3rd power, that has no n's attached to it. That's just some number. And what it turns out is we're going to be able to take that number and just put it in front of the series. So let's do that next. Since again, there's no n's attached to that, we have minus 5 raised to the minus 3rd power, and then we have the series from n equals 0 to infinity, minus 1 to the n, all times minus 5 to the 2n power, all over 2n factorial. And now we see we have all of the stuff inside the series in basically the cosine form that we need. We have that minus 1 to the n, that 2n factorial in the denominator, but now we have something in parentheses raised to the 2n power. So we can rewrite this series term basically as cosine of minus 5. However, we still have that additional term sitting out in front of that series. So this additional term, we're actually multiplying onto that cosine of minus 5. So we get that this is minus 5 raised to the minus third power times cosine of minus 5. Which, just using some extra algebraic practice here, since we have that minus 5 to a negative number power, we can rewrite that as a 1 over minus 5 cubed, all times cosine of minus 5. So again, this series that we're handed at the beginning of the problem, this is just equal to some number, and that number just happens to be, in this case, 1 over negative 5 cubed times cosine of minus 5.